Hello and welcome to this video about solving quadratic equations with square roots. The learning target for this video is using square roots to solve certain quadratic equations. Now let's underline that word, certain quadratic equations. One of the first big ideas I want to get here is that this is sort of, almost you can think of it as like a hack for certain types of equations. So a hack for certain types. In other words, this isn't a method that's always going to work, but this is a method that's good to have in your back pocket for when we run into these situations. So, the big idea, we're going to use square roots. Let's just keep it real simple and say we had x squared is equal to 4. Now, typically, when we go to solve quadratics, we want everything on one side and 0 on the other side. Here, that's a little bit overkill because we have our variable isolated, and we can use an operation to get the squaring away. We can simply just take the square root and we're done. But now what we have to remember is that when we take the square root of x, that we're actually going to end up getting two options here. X could equal 2 or negative 2. And usually what we'll do is to shorten that, we'll just go x equals plus or minus 2. Because if we were to plug that back in, we were to take 2 and square it, we'd get 4. If we take negative 2, if it's in parentheses and we square it, we will also get positive 4. So either way, we're going to get positive 4 out of that. So as we take a square root, we're going to get two possible answers. So that's the other thing that we need to remember, is that we're going to have a positive and a negative solution. So now let's go through some examples. I'm just going to hammer through a handful here to kind of show you how this works. So for this first one, we'll kick it up a notch from what we just saw. Let's say we have 2x squared is equal to 50. All right, now if I wanted to, I could take the square root of both sides. However, that would maybe be a little bit frustrating because this 2 here isn't a perfect square, so it doesn't do me much good to take the square root of it. So what I'm going to do first is get x squared by itself. So now that 2 goes away. I have x squared is equal to 25. And here I can take my square root. X equals plus or minus 5. Let's do another one. This one, let's have our coefficient be a perfect square. So we'll go with 4x squared is equal to 9. Now if I want to, I could take the square root. However, I still think that's going to make things somewhat complicated. So I'm just really going to emphasize, hey, let's make sure that we only have x squared or something squared on this one side. So divide both sides by 4, divide both sides by 4, and then we'll end up getting x squared is equal to 9 over 4. Now, you might be panicking and thinking, how am I supposed to deal with fractions? Well, take the square root of both sides, and what we do with the square root here on the right-hand side is we're able to kind of just focus on the numerator and the denominator separately. What's the square root of 9? What's the square root of 4? And so when we do that, we end up getting x is equal to plus or minus 3 over 2. Box it, walk away. Now, before I go into, or actually, let's kind of do several examples here of some other looks we can get here. All right, so I'm just going to kind of, again, do a few. Now, let's say we have something like x squared is equal to 17. Well, here, take the square root of both sides. The catch is 17 doesn't have a square root. Now, if you want to, you could use your calculator and find a decimal equivalent, or you can simply say x equals plus or minus the square root of 17. And that is a totally acceptable answer. Another thing I want to point out is if we had something like x squared is equal to negative 4, we try to take the square root of both sides, we can't do that. Because square roots, this always has to be positive. So set that there, has to be positive. So in other words, you might have no solution as an answer. Okay, so just wanted to throw that out there. If you run into a negative number, you end up, or trying to take the square root of a negative number, you'll get no solution. Okay, now let's get to the hard examples. For our first one, let's go with 3x squared minus 11 is equal to 7. Okay, this looks very similar to a linear equation, except we just have x squared. Now, again, this is a good situation for maybe using solving by square roots because we don't have any regular x's. So essentially, solving for square roots is great when we only have one x that is squared. So what I'm going to do is try to get that by itself. So I'll add 11 to both sides. 3x squared is equal to 18. Now I divide both sides by 3. Again, I want to get the x squared by itself. And I have x squared is equal to 6. Take the square root of both sides because square roots undo squaring. And we'll have x is equal to plus or minus square root of 6. Box it, walk away. So again, what we're seeing here, a couple of things. One, we can totally have our answer be a square root. Two, this is a great method if x squared is the only variable in there. If we have another x, then we got to start thinking about other methods. But just x squared, we'll just kind of go with solving by using square roots. Okay, I have two more examples for you, so bear with me. We're almost done. So our next one, x minus 2 quantity squared is equal to 9. Now, you might be thinking that this is a different look, and it totally is. However, the process remains the same. We essentially have something squared is equal to something else. As long as we have nothing else on this side of the equation, and because it's all bounded in parentheses, it is totally cool to take our square root at this point in time. When we do that, we'll get x minus 2. All right? It's just taking care of the square, or the square root takes care of itself and the squaring sign. So we've now opened up the parentheses, and on this side we have plus or minus 3 square root of 9. Now here's where we have to be careful. We're going to add 2 to both sides, and we're going to get 2 answers, 2 solutions here. We're going to get x equals 2 plus 3. We're going to get x equals 2 minus 3. So in other words, x will equal 5 or x will equal negative 1. And that all stems from the fact that when we take the square root of a number, we can get plus or minus. So we have to consider both of those. So here we have 2 answers. Now our final one is going to be 6 times x minus 4 squared minus 1 is equal to 41. All right, here, very similar to what we saw at the very, very top, right there. But again, what we have is we're kind of combining what we saw with that last problem as well, where we want to get this whole thing by itself because this is what's being squared. So I'm going to add 1 to both sides. Now I have 6 times the quantity x minus 4 squared is equal to 42. I don't want 6 here, so I'm going to divide by 6, and now I have x minus 4 quantity squared is equal to 7. This is what I want. I want whatever's being squared on one side and then everything else on the other side. Take the square root of both sides. Here, I release the x minus 4 from its parentheses, and then I'm getting an awkward part of the answer over here, plus or minus square root of 7. And just like I did up here, I have 2 solutions I got to work out. I'm going to have x equals 4 plus the square root of 7, and x equals 4 minus square root of 7. Again, seems awkward, but it's a totally acceptable answer. So that's how we solve quadratics using using square roots. Again, it only works for certain cases. So right here, you have certain cases where we essentially just have one variable squared. We then use the square root property to undo that and get some solutions. Good luck with your homework or practice, and let me know if you have any questions.